For lesson 96, we're looking at polar coordinates. Basically what we're doing is we're introducing a brand new coordinate system, something other than our old-fashioned Cartesian plane. You know, if you think of the Cartesian plane, we always had an X and we always had a Y. It's a very nice system. There's nothing wrong with it. It works fine. You know, it gives us a nice location, which is basically what we use it for, to identify a location from the origin. Today we get into a second type of plane, something totally different. It's called the polar coordinates. And here's how it works. You know, just like with Cartesian we had X and Y, we're going to have two values again today. With the unit circle, we always started here on the right. So it's the same concept, but now we're going to call it the polar axis. It's essentially angle 0. So we start here on the right, and then we work counterclockwise, just like we did with the unit circle. 0, pi over 2, pi, 3 pi over 2, back to 2 pi, and around if we wanted to again. Okay, this is going to be our origin. They refer to it as point O. We also can call it the pole. Or origin. First thing that we're going to do is we're going to indicate the angle as to which we're going to go. Okay, so maybe I want to go 45 degrees northwest or 35 degrees southeast and so forth. So we're indicating a particular angle as to where we're going to head. And then from there, now that I have that specific angle, all I need to be told is, okay, how far do I walk? Okay, or how far do I go? And that's my value R, which, as you can guess, basically stands for radius. So we're going to be told an angle as to where we're going to be directed to, and then distance to where we're going to go, R. And at that point, we have our polar coordinate R, comma, theta. So again, just like we had X, comma, Y, now we have an R, comma, theta. R again is the directed distance. Theta, as always, is the angle, or directed angle. Anybody see the new Battleship movies? You know, they'll tell them, okay, I need to point this weapon at, 45 degrees east, and then they tell them how far out they are. Boom, there they go. Angle, distance. It's a nice clear-cut way of, again, identifying a location from where you're at. So we have these two different coordinate systems now. We have Cartesian, we now have polar, and the thing is, we need to be able to know how to go back and forth between the two of them. You know, they could give you polar, then they're going to ask for Cartesian. That would be this one. Polar to Cartesian. This is what we're going to use. Or vice versa. Could give you Cartesian, but now we want to come up with a coordinate pair to identify that location. So this is going to be the heart of the lesson, just being able to learn how to go back and forth between the two of them. I do want to provide a quick demonstration of how this works. Let's start from polar to Cartesian. Why is it X is equal to R times cosine of theta? You know, this thing isn't magic. It isn't just wave your hand and there it is. There's got to be a reason behind it. Well, if we're given our coordinate plane, and this is our starting location, and say I want to go to this point over here. Again, we can draw our right angle. This here is going to represent our x value. This would represent our y value. Okay? And so forth. But now suppose we want to introduce our trig functions. If this is theta, and if we identify opposite, adjacent, and hypotenuse, this now would be your opposite, this would be your adjacent, and this would be your hypotenuse. The other thing that I want to include here is your distance r would be that r value, so that's where that's going to come into play. And if we use our trig functions, let's start with sine. Sine of theta, opposite over hypotenuse, correct? So if we look at the opposite over hypotenuse, opposite over hypotenuse, and if I substitute it in, it was essentially y over r, correct? And again, if we wanted to solve for solve for y then would simply be multiply both sides by r times the sine of theta. And that's why we have that one there for our y value. Cosine would work the exact same way. Cosine of theta is equal to adjacent over hypotenuse. Notice our adjacent side is the x, hypotenuse side is that r. Cross multiply. X is equal to r times cosine of theta. So again, not really magic, just understanding how we go about using our trig functions and identifying the parts that go along with those. We're given 2 comma pi over 2, which is a clear indicator that this is a polar coordinate because they have a pi in there. Direction, theta, it's an angle. So our angle is going to be pi over 2, and we want to convert this polar coordinate to our Cartesian. Polar to Cartesian. X is equal to r times cosine of theta. What's my r value here? What's my theta? Very good. Now if we make a quick sketch of this, pi over 2, here's 0, here's pi, there's your pi over 2. So we're essentially going straight north, right? And what's my distance? Well, distance is 2. Cosine is which variable, x or y? X, so therefore at pi over 2, what's your x value? We stay right on the y-axis, our x value is 0, right? If you were to plug that into your calculator and make sure you were in radian mode, cosine of pi over 2, okay, it would tell you it's 0. Therefore, 2 times 0 will get us 0. We find our y. R times the sine of theta now. Radius is still 2. Theta again is pi over 2. Sine is our y value. What's the y value on the unit circle at pi over 2? It would be 1. Again, your calculator would tell you the same thing. 2 times 1, there's 2. So we found the x to be 0, the y to be 2. There's our ordered pair. If we do this, if we walk 2 miles or 2 units in the direction of pi over 2, it'll give us to the location 0, 2. On your own, let's go 2 comma negative pi over 6. What's negative pi over 6 equivalent to? What's the positive radian measure?
Over 2 pi.
No.
No. 1 over pi is 6 pi.
You know, if we identify pi over 6, if it's just positive, it would be over here, right? That's at your 30 degrees. So what would negative pi over 6 be? Well, we'd just go down 30 degrees. 360 degrees in a full circle, so that's here at the 330 degrees, or 11 pi over 6. Make sense? We're going backwards that amount. So down. So we do have this ordered pair on our unit circle. Cosine is which value again? X. So for that cosine of negative pi over 6, the x value there is the square root of 3 over 2. And 2 times that amount is simply the square root of 3. If we go to y, again, it's still the same, square root of 3 over 2. Sorry, not square root of 3 over 2. The y value now is negative a half. So negative 1. And now let's make sense of this thing. Let's make sure it seems reasonable. You know, again, negative pi over 6 indicates that our angle is going to point us down into quadrant number 4, right? So if we look at that ordered pair, if this thing is going to be down in quadrant 4, then I know my x value needs to be positive, my y value needs to be negative. Does it work out that way? Absolutely. We got a positive square root of 3 and a negative 1. And it looks about right. Okay. That's the easy direction when you go from the two. Now we're going to go from Cartesian to the polar coordinates. Essentially what we need is we need some r comma theta. We need to identify a radius, and we also need to identify a theta. Now let's go back a little bit. I forgot to mention this to you. If we look at what they give us the tangent of theta is going to be equal to y over x. And what we really want is just theta, right? So let's go even a step further with this. Instead of saying it's the tangent of theta, let's just solve for theta. Because ultimately, that's what we're going to do. We're going to take the x and y and we're going to plug it in, and then we're going to solve for that angle. Same idea with here. You know, there's the r. We could solve for it, but let's go ahead and do it. How do I get rid of the exponent of 2? Well, we're simply going to square root both sides. So the book really should have just gave you this and this. We'll do the step for them, I guess. So again, we need to solve for r and we need to solve for theta. Let's start with that r value. R is equal to the square root of the x squared plus y squared. X value is negative 3. Y value is negative 3. So it's telling us we got a distance of square root of 18. Can we break that radical down? Factors of 18 are 9 and 2. And what's the square root of 9? 3. There is our r value. If we go and solve for theta, it said that theta was equal to the inverse tangent of y over x. My y value is -3, my x value is -3. So essentially we're looking at the inverse tangent of 1. What will our calculator give us? What's that? 45? That's if you're in degree mode, right? Okay, which is fine. Actually, we want to do that. Because what would it give to you otherwise if you were in radian mode? It would give you the decimal because it's an irrational number again, right? Because we're using pi. So let's use that idea. Jaden said if we punch this in degree mode, it's 45 degrees. So let's go to our unit circle. What's our radian measure at 45 degrees? The radian measure? Yeah, pi over 4. Problem is, this is not the correct answer. Shoot, right? But they told us to use this template. It said, theta is equal to the inverse tangent of y over x. I was supposed to be able to use that, plug it in, and get my answer, right? But it's wrong. So they lied to us. In a way, yeah, they did. Remember the idea that the unit circle always gave you 2 possible answers? Okay? The same thing is happening here. When we say pi over 4, what it is giving you is it is giving you this angle right here. There was our 45 degrees, or the pi over 4. But again, what was our ordered pair to begin with? -3, -3. It was over here, right? Well, I can't walk northeast if I want to get southwest. I'm walking in the wrong direction, right? So again, this is the calculator giving you the one answer. Here is the second answer. So at this point, between you and your elbow partner for the next 30 seconds, what is that angle right there? I need the radian measure. Because anytime you work with polar coordinates, again, it's in radians. Okay, let's go to Jeremiah and Kyler. Answer that we come up with. What's this angle right here?
5 pi over 4.
Jaden, you agree? Yes, it is. Okay. Essentially what you're doing is you're going in the opposite direction. What this angle is creating for you is a line. We got the first half of the line over there. What the calculator didn't give you is the second half of the line. Okay? If it was down here, it might give you that answer, but the real answer might be over here. And that's why we don't like going in this direction, because the idea of having 2 possible solutions. Calculator can only give you one. Okay? I've yet to see a calculator that'll give you both of them. Okay? So this is where we are more powerful and we are also smarter than the calculator. Right? You are smarter than the calculator. We have reached that point. Final answer that we need to write. Is it r then theta or theta then r? R theta. 3 3 squared to 2. That's the distance I need to walk. But the angle that I need to walk at is no longer pi over 4, but now 5 pi over 4. Use your logic. When they give you the Cartesian ordered pair, just make a quick sketch of it. You know, if I give you -2, 1, just do a quick sketch. There's my -2, there's my 1. So I know that my angle measure, my radian measure, has to be somewhere between pi over 2 and pi. Has to be. If I have the other one, it's the wrong one. Make sense? Last thing we're going to look at is graphing these two. When we worked with XY ordered pairs, these were really easy. You know, 4, 0, that's simple. 4 units to the right, I don't go up. There's that value. Or if I give you 0, -2. Okay, we could do that one. 0 left or right, and then down 2. Okay, that's fine. The problem is sometimes they won't give you the r or the theta. So this thing gets kind of screwy for us. You know, if they just give us r again represented what? Well, it was the distance from the origin, right? But do they tell us at which direction to go? No. Okay, so how is that going to look? Well, if the distance is 2, it could be that point, it could be that point, it could be that point, it could be that point. It also could be this one here, this one over there, this one here, this one here. This is a distance of 2, that's a distance of 2, which essentially forms a what for us? Circle. If you have a radius of 2, we don't know which way to go, but we do know is if I'm on that circle, I'm 2 units away from it. So anytime they give you an R2, it's a circle. R3 would be a circle with radius 3. R4 would be a radius circle with radius of 4. And for B, here they just give us the angle at which we're going to walk, but they don't tell us how far to go. So pi over 6, again, if you look at your unit circle, that's at 30 degrees. So we're walking over here at this angle. But again, I don't know how far to go. Your buddy might tell you, hey, walk at pi over 6 until you get to your destination. You'll find it. Okay, it'll be sitting there waiting for you. But again, here's only half my answer. This is the answer the calculator would give you. What else do we got to do to this thing? Well, finish the line going off to the left. We will do a couple of these when we get back.